doing 4.3 part 2. The date is 1/18/21. This is what I talked about today on that date. All right. So it says consider the area, the sum of all the heights of rectangles times really narrow, tiny widths. Dx is a really small width on a rectangle times the heights of the curve at that height for that rectangle, and add them all up from A to B, and that would give you the approximate area A1. If you do this infinitely small, that's what we do in the limit of our sums, and that's what this was about, the sums limit. So it makes it infinitely narrow times the height. That gives us the area under A1. And from B to C will give us the area 2. And if we wanted the area from A to C, that would be area 1 plus area 2. Now, and so they come up with this idea down here that the area under the curve from A to C of a function, under the function f of x, using really tiny rectangles, will be the area from A to B plus the area from B to C. A question that sometimes arises is, what if A, B, and C are not in that order? What if, for example, this was C and this was B? Well, then the area from A to B would be all of this, and the area from B to C would be from here to here, which is backwards, so that would make this area negative. And so if we take all of the area, A to B, if B was over here, and subtract the area from C to B, or add the area from B to C, but it's backwards, so it subtracts it, you would get this area, which would be from A to C, which is what that says. So it really, and you can play with the other possible ways this could be, B, A, and C, or whatever, and you'll find out that this formula always works no matter what order A, B, and C are on the graph. So that's one of the first boxes that you're supposed to know. Next thing is, what happens if the limits are backwards? So let's take a look at a function. Let's say it's like this, and there's A, and there's B. And if the area from A to B is here, and it represents, if you were to work this out, you would take the antiderivative and evaluate it from A to B, which means you put in B, and you get f at B minus f at A, and that would give you this area, and it would give you a positive amount. But what if you go from B to A instead of A to B? That's working it backwards. And what would happen would it would turn these two around, and you would get f of A minus f of B. Now, how do these two relate? If you subtract two numbers like 5 minus 3, and then switch it to 3 minus 5, the difference between these two is this is 2 and this is a negative 2. It changes the sign, and that's what they're trying to say. If you're going from A to B, and then you switch to B to A, it will change the sign of whatever A to B was on the answer. Another thing you might note on this is f of B really is the area from 0 to B. And f of A is the area from 0 to A. And so the area from 0 to B minus the area from 0 to A is the area from A to B. Okay, next thing. And this one's about, what if we multiply by a number? So they drew a random f graph, and then they drew what they said was 2 times f graph. So it's twice as high. Now to verify that, if you take, let's see if I can do this here. Let's do this. So if I take A, and I mark it, this is the height there. And we'll do it again, the height of the curve at 0. That should be the height they have over here. You notice it is. Let's take the height at the highest place here. So that would be from here to there, and do that height again. So there it is, twice that height, and that's what they should have put here for that highest place. And you notice that's really close to what they did. And they did that all the way along. Now, if you were to calculate all this area, they're talking about this particular rectangle, but if you were to calculate all this area, and then to calculate all this area, since this one is twice as tall but the same width, the area should be twice as much. And if it was 3 times as high, it would be 3 times as much. And if it was half as high, it would be half as much. And so they're saying, if there's something that's multiplied times the function, here's the function, and you multiplied it by 2, well, you could just find the area under this and double it. So find the area under F and double it or triple it or whatever K is. So in other words, you can pull the K out of an integrand. So if it's 2 times f of x, that's going to be the same as twice the area under f of x. Okay? Then we have a little exercise here. So let's try to understand what they were doing here. So it says the area under F from 0 to 2, doing really tiny rectangles, is -3. So whatever F is, from 0 to 2, the total area is -3, so there's more below the axis than above. Now it could be all below the axis, and be -3, or it could have some above and more below and make the sum of those two -3. And then from 2 to 5, the total area is +2, which means there's 2 more units above than below. Now it could look something like this, where this is 2 more units than that, or it could be just like this, where this whole thing is just 2. But anyway, the area under the curve F from 2 to 5 is 2. G from 2 to 0 to 2 is 4, and 2 to 5 is -1. And x squared from 0 to 2 is 8/3. Now that should not be a surprise to you, because if we go from 0 to 2 of x squared dx, the antiderivative for x squared, let's see, the thing that you would take the derivative to get x squared, would have to be an x to the third, because the power goes down by 1. And when you take the derivative, you take 3 times this to 1 less power. So if we multiply by 3 and end up with 1, there must have been a 1/3. So 3 times 1/3 would be 1x, and then that would be 1 less than 3, 2. So there's the antiderivative, and we're going to calculate it from 0 to 2, which means we put 2 in here. 2 to the third, 2 times 2 times 2 is 8, times 1/3 is 8/3, minus, then you put 0 in. 0 to the third is 0, times 1/3 is 0, so we get 8/3, like they said. Now, if they say to do it from 2 to 5, we would have to evaluate 1/3 x cubed, the antiderivative of x squared, from 2 to 5. Well, when we put 2 in, we got 8/3 minus, and then we put 5, we get 125, 5 times 5 times 5, times 1/3, so it's 125/3, So 8 minus 125 is 117 thirds, which is what they said it was. So we didn't have to do that calculation, but I just wanted to show you how that works. For x to the third, the antiderivative would be 1/4 x to the fourth, because if I took the derivative of this, it would be 4 times 1/4, 1, x to the 1 less than 4, 3. So I'd put in 2, and then I'd put in 0, and you should get 4. If you put in 5, and then put in 2, and subtract them, you should get 609 over 4. You can check that in this. But anyway, this we weren't supposed to question that, but I'm just trying to show you how you got that. We're supposed to try to figure out what this is. Well, the area under f of x from 2 to 5 is 2. But they said from 5 to 2 and not 2 to 5. They turn these around. And if you remember from just a little bit ago, if you turn them around, you get the negative of what you got before. So the answer to this is -2. B, the area under G from 0 to 5. Well, from 0 to 2, there's 4, and from the rest of the way, 2 to 5, it's -1. The area of this will be 4 plus a -1, which is 3. Now, f plus g, we can do this by just finding the area from 0 to 5 of f, and then find the area from 0 to 5 of g. And 0 to 5 would be this plus this, which is -1 for 0 to 5 of f. And 0 to 5 of g would be 4 minus 1, which is 3. So we'd have -1 plus 3, which is 2. Okay, from 2 to 5 of 3x squared minus 4x to the third. Well, 2 to 5 of x squared, 2 to 5 of x squared is 8/3. But this is 3 times it, so we can pull the 3 out for this part, and so it'd be 3 times that, 8/3. Minus, and then you can split adding or subtracting, so we can split this, we can pull the 4 out, so the area from 2 to 5 of x to the third is 609 over 4, but it's times 4, and we're supposed to subtract. So 3's canceled here, we get 8, 2 to 5. Oop, I didn't do 2 to 5. 2 to 5 is 117. I did this in class too. X squared from 2 to 5, I did from 0 to 2. 2 to 5 is 117 over 3. So these cancel, so we get 117 minus 4's cancel as 609, which is 5492, I believe, and negative. All right, the last one. So this would be, this is 0 to 5, 5 to 0, so this is backwards. So if we do 0 to 5 of x to the third, that would be 4 plus 609 over 4. But it's doubled, and it's backwards, so it's minus. And then we have -7, we can pull that out, and from 5 to 0 of g, well, 0 to 5 is 4 minus 1, 3, but it's backwards, so it's -3. So we get -8. 2 times this would cancel, so make it 2, and so we get negative because of the negative, and half of 609 is 304.5. And minus 7 times minus 3 is plus 21. And so we have negative 8 and negative 304, so that's negative 312.5 plus 21, which equals, see, 21 from this would make it 291. Now, I think I made a mistake because I think it's supposed to be 292. Half of 609 is 304.5. Minus 8 minus 304.25 plus 21. That's minus 312. 1 from 2 is 1, and 2 from 1 is 9. And minus. I thought I had got 292. Anyway, this is the idea. It looks like that's 291.5. All right. Finally, what's average value? Now, they go through a lot of mathematical stuff, but I want you to understand it in common sense terms. So this is the area under f of x. Now, they make a picture that looks like this. And so it would be this area. Now, imagine, if you will, this was sand between two plates of glass, not very far apart, and has boundaries here. And so if it somehow is being held in this shape, maybe by a piece of wire or a stick or something like that, or cardboard or something, if you remove that and shake it a little bit, the sand will fall and will flatten out to some height here. The sand that was higher will start filling in down here, so that eventually it'll reach a level where all the sand here ends up down here, and we get a shape that looks like this. Well, the average height of a curve is defined by the height that it would settle to if it was evened out. So, all of this area will equal the area when it's evened out. So all of the area is the integral from a to b of f of x. And if that's the area and we want to make a rectangle, it will be length times width, or width times height, probably better here, width times height. And we want to know the height. So we would take the total area and divide by w, the width, to get the height. That would be called the average height, or the average value of a function. Well, the width is from a to b. To find it, you would take the length of b minus a gives you the width of the rectangle, b minus a. So the average height will be this divided by b minus a. Now, they don't write it this way. They say, well, that's the same thing as multiplying the area by 1 over the width. 1 over the width times the area will give you the average height, which is called the average value of the function. Now, just a little practice here. They said, suppose that the velocity is this equation, and it's telling you where the object is instantaneously. So this is the instantaneous velocity, and it's measured in minutes and in meters per minute. So what does this look like? Well, hopefully you're starting to recognize this as a semicircle. If you take x squared plus y squared equals r squared, that's a circle. And if you solve for y by subtracting x squared and taking the square root, and if you just do the positive one, you get the positive half of the circle. Well, it's not x, but t, and this is the radius squared. So the radius is 2, and this graph is shifted 2 to the right. So 1, 2, and the radius is 2, 3, 4, 2, and so it would go up to 2 and then back down to 4. So that's what the velocity is looking like. So it looks like the object started and quickly accelerated, got up to a speed of about 2 meters per minute, and then slowed down to 0 again. Okay? So sketch it. What kind of curve is it? It's a semicircle, half a circle. Evaluate the area from 0 to 4 on the velocity curve. Exactly. Well, half a circle, let's see. Area of the circle is pi r squared, and since the radius is 2, 2 squared is 4 pi. The whole circle would be 4 pi, so this is 2 pi. And what does this mean in terms of the object moving? Include your units. Well, it means that the object moved 2 pi meters. 2 times 5 is approximately 6.28 meters in the 4 minutes. Meters per minute was the velocity. Okay, determine the exact average of the velocity over 0 to 4. Well, if this is the total area, and we learned that 1 over the width of the interval times the total area and the limits here would be 0 and 4, so 1 over 4 minus 0 is 4, times the area under this curve is 2 pi, which means it's pi over 4. And see, this would be meters times 1 over time, the minutes. 4 minutes is the width of the interval. And this is meters. So we get meters per minute, which is an average velocity. And, pi over 2. 1/4 of pi over 2. 2 goes into 4, 2. Pi over 2. And half a pi is it's approximately 1.57 meters per minute. So if I go back to my graph and draw at 1.57 a rectangle, that rectangle should look like the area under it is equal to the area under this semicircle. So there's some extra here that fill there and some extra here that will fill here and make it equal. So what is the exact height of the rectangle? It's pi over 2 meters per minute. And how can you use the average value to compute the total distance traveled by the object moving in 0.4? Well, if it travels at pi over 2 meters per minute on average for 4 minutes, the minutes cancel, the 2 goes into 4 and leaves 2 pi meters, which is what we said it was already. That should be it. That's kind of what I presented today in class, and so you should be ready to go work on the homework, which will be due on the 19th, Wednesday.